లింక్ వచ్చింది కానీ నేను ఎంటర్ కావచ్చు. నేను ఎంటర్ అయ్యాను నాకు స్ట్రీమ్ చేసి నేను ఎంటర్ కాదు ఆల్రెడీ మన దాటినాను కదా. ఇప్పుడు నేను ఖచ్చితంగా నేను కంపల్సరీ ఉండాలన్న. అదే స్టూడెంట్స్ ఇంత వెయిట్ చేస్తుంటారు కదా. ఇప్పుడు లాగౌట్ అయితేనే ఆటోమేటిక్గా కట్ అయిపోయింది. మంది అయిపోయినారు కదా. ఇక్కడ ఖాళీ ఎంటీ వస్తాను అనమాట. లింక్ వచ్చింది కానీ యూట్యూబ్లో ఎంటీ వస్తా ఉంది. నేను అది వచ్చిన కానీ నేను ఎంటర్ కావచ్చు. నేను ఎంటర్ అయ్యాను స్ట్రీమ్ చేసి నేను ఎంటర్ కాదు ఆల్రెడీ మన దాటినాను కదా. ఇప్పుడు నేను ఖచ్చితంగా నేను కంపల్సరీ ఉండాలి. నేను వాయిస్ అవుట్ వస్తాను కంపల్సరీ ఉండాలంలో ఖచ్చితంగా నేను ఆన్ చేస్తేనే అదే స్టూడెంట్స్ ఇంత వెయిట్ చేస్తుంటారు కదా. ఇప్పుడు లాగౌట్ అయితేనే ఆటోమేటిక్గా కట్ అయిపోయింది. మంది అయిపోయినారు కదా. ఇక్కడ ఖాళీ ఎంటీ వస్తాను అనమాట. లింక్ వచ్చింది కానీ యూట్యూబ్లో నేను ఎంటర్ కావాలా మీట్లోకి. నేను లాగౌట్ ఎంటర్ నేను స్టూడెంట్స్ ని ఒక 5 మందిని ఒక 2 డ్రాప్ అవ్వని చెప్పండి. మళ్ళీ జాయిన్ అవ్వండి. నేను కంపల్సరీ కంటిన్యూ ఉండాలి. నేను వాయిస్ అవుట్ వస్తాను. నేను వాయిస్ అవుట్ వస్తాను మీటింగ్లో ఖచ్చితంగా నేను ఆన్ చేస్తేనే అదే స్టూడెంట్స్ వెయిట్ చేస్తుంటారు కదా.
represent a point in a space, right? So it's purely about how you represent a point in a space. So there are different type of coordinate systems, right? You have a rectangular. You are going to represent a point as x, y, z. You have a cylindrical. You are representing it as rho, phi, z. You have a spherical. You are representing it as r, theta, and phi. But ultimately, in each and every type of system, what you are going to do, you are going to represent a point in a space. The funda remains same. Now the question comes, why there are so many different types of coordinate systems, and which coordinate system is in a space? So the answer to this question is purely about how you represent a space. So there are different points you are doing. You have a rectangle, you are going to represent a point as a point as x, y, z. You will have cylindrical convenient to you. You are representing it as rho, phi, z. Whereas being a mechanical engineer, you have spherical, you are representing it as r, theta, like a surface tension and viscosity problems. But ultimately, each and every type of system problem, what you are going to do, you are going to represent a point in a space. The funda remains same. Now the question comes, why there are so many different types of coordinate systems, and which coordinate system represents in a space. So the answer to this question is purely about how you represent a space. So there are different types of coordinate systems. Nothing but the way how you represent a point in a space, and the actual application will demand which type of system has to be used, right? So anybody have any questions here? Mechanical So this is my point and measure the angle from x-axis. This is called your phi. So to be technically defined, the phi is called the azimuthal angle. So don't get confused here. Azimuthal refers to the horizontal plane and elevation refers to the vertical plane. So since you are measuring the phi in a horizontal plane, that is your xy plane, I can call it as a azimuthal angle. So phi is the azimuthal angle with respect to positive x-axis. And let us have a look on the z value. So as I defined in rectangular system, right, once the point is in the space, the distance of this point from the xy plane is called your z. As you can see in this diagram, the distance from here to here is same as the distance from here to here. So I can say this is also z. In the same way, the distance from z-axis to the point and the distance from origin to the projected angle from this also same. This is called your phi. So to be technically defined, the phi is called the so when I look into the z right now, z is something looking like, so don't get confused here, azimuthal refers to the horizontal plane. And elevation refers to the vertical plane. So since you are measuring the phi in a horizontal plane, that is your xy plane, along the reference line as a azimuthal angle. I can say the reference line here is nothing but your z-axis with respect to positive x-axis. Right? And let us have a look at the z value. Is the distance from the as I defined in rectangular system, right? To measure once the point is in the space, so the distance of this point from the xy plane x-axis is called your, and the z is the height of the point along the reference line. As you can see in this, so when you look at the symmetry, the distance from here to here, what is the definition? Same as the distance from range of here. So I can say this is also z. Can you take the negative values? In the same way, the distance from z-axis to the point
0 to
and the distance from origin to the projected angle from this also 6. This is called your phi. Very good. Excellent. Rho value to be technically defined, phi is called. So when I look into the z right now, so z is something looking like value. So don't confuse the azimuthal refers to the infinity. Very good. So we can say before defining phi, so since we are measuring the phi in a horizontal plane, that is your xy plane, the reference point as a azimuthal angle. We already discussed. I can say that is so in order to understand what is the range of phi, let me give a respect to positive x-axis. Consider this is your x-axis. Positive x-axis. Let us have a look at the z. This is my origin from the so let me start with the space. Initially, the distance of this x-axis is called your, and the z is the height of the point in the positive x-axis. So when you look at the symmetry, the distance from this to here, what is the definition? What is the range of two? So I can say this is also z. Can you take the negative angle from positive x-axis corresponding to 90 degrees? The distance from z-axis to the point, when you are suppose here, the distance corresponding to 180 degrees, this is 6. When you are suppose here, the total angle will be 270 degrees. And again, when you are taking by the z, as you can see that when you are taking the negative value, so I can say the value is ranging very low. 0 to 6, and the type of symmetry, as I already said, I already know all this. What is the range of phi? Let me give it a x-axis. Consider this is your x-axis. Axis is also called as a line. Positive x-axis. So let me start with the space. Initially, so anybody having questions here? You just please ask one more. So since I was on the positive x-axis, so when you look at the symmetry, so give a simple hint to once you are able to divert, how I define the positive x-axis corresponding to 90 degrees, the distance from the imagination clear. The subject is distance corresponding to 90 degrees. So just try to concentrate on understanding all these total angle 270 degrees. And again, if you are not particular about it, I will be able to tell you that I can take it to the value. So ranging very low. So let's go to the spherical point. So in the spherical system, the point is represented as symmetry, as I already said. So again, I was considering this I will also make any difference. This is your x-axis, this is your y-axis, axis is also called as a line, positive x-axis, and the point is the same. This is represented as are able to dissect what is the difference and how it is defined right here. So arc is the radial distance. Make the imagination clear. The subject is very interesting. From origin, concentrate on understanding all this imagination. And what about theta? So first, draw a radial line from the origin direction. Point here. So what you have to do? Draw a radial line from the origin and measure the angle from the z-axis. So let us go. So we have one line with your radial line. So in this one, the other line with your z-axis. So angle is called what? So since theta is measured in a vertical plane, as I said, we can call it as elevation axis. This is your y-axis. Axis is also called. This is made with respect to the z-axis. And next, going back to the fact that the definition remains same. So project the point into the dot plane and draw a line from the origin. Your point you have one radial line like this on the other one is x-axis. You are able to dissect. This is called your phi. Right here. So since phi is measured in a horizontal plane, we can define phi is an azimuthal angle from origin. That is with respect to your positive x-axis. And what about theta? So first, draw a radial line from the origin point here. So can anybody say what is the distance from origin to this particular point? So we have one line with your radial line. So what is this particular distance? Anybody? Just I would like to test your understanding. So excellent. What's your name? Very good. Excellent. I thought you would have been with answer as far. And excellent because as you can see here, point most of the time what everybody used to confuse. Sir, you mentioned this as R line, so I can say this is also my R. No, to be honest, if you see really like, when I draw a line from here to here, if it's a cylindrical system, what is that? Place is nothing but your rope. You can define phi is an axis. So since this and this both are same, this is actually your rope with respect to your, let's say pointed out, related to r sin theta, which we'll discuss in the next class. Okay. So don't think that this is nothing but r. What is the distance? Rope. R is this particular. So next, coming back to the range, so the value of r can take any value from 0 to infinite, as the radius cannot take negative values. I would like to test your understanding. And what about theta? Excellent. What's your name? Theta is ranging from 0 to 180 degrees, right? And phi is ranging from 0 to 2 pi. I will tell you why theta ranges up to 180 degrees. There is a point to be noted here. So theta is measured because I respect to the entire z-axis. Most of the time, what everybody used to confuse. So what I mean by that, suppose this phi is your z-axis, positive z and negative z. To be honest, and when the point is somewhere lies on the positive z-axis, what is the value of theta? It is a cylindrical system. What is that? Place is nothing but your rope. Suppose when the point is here, so since this and this we call it as b, this is actually your rope with respect to either you can measure the angle from positive z or negative z, right? Or in our context, so it corresponding to 90 degrees. So don't think that even when the point is here, see rope, you can measure it from negative z or positive z. The next 90 degrees only. So the value of r can take. So since your entire z-axis is the same, right? What is an observation we can make? Even if you are lying on this side or this side, theta remains same to 180 degrees, right? And phi. So in other words, whatever the angle covered in this half cycle, there is a point to be noted here in this particular half. Theta is measured because I respect to the entire z-axis. So what is the maximum angle when you say in such case? Whatever is covered in this, again the same thing. So the theta value ranges from one half cycle, which is from 0 degrees. Suppose from 0 degrees up to 180 degrees. I hope it is clear. And either you can measure the angle from positive z or negative z, right? And when you look into the type of symmetry, all these r and where the point is defined by with respect to the r is and the orthogonal point, right? So I can say there is a point. Your entire z-axis is let me give a practical example so that you can clearly understand why the phi is ranging from 0 to 2 pi and theta is ranging from 0 to pi. So first let us have one theta and give a simple example so that you can understand it better. So consider that this is your z axis. Positive z and negative z. And the person who standing exactly like the origin. And there is a big tower, very, very big tower, which is in front of him. This is a very big tower. Now, I want to measure the position of this person. He's looking at this particular tower. So if you want to, this guy, if you want to look at the top of the tower, he has to completely opens up his head completely into the positive side. And if you want to see the bottom of the tower, which is extending infinitely down, he has to make completely down. Right? Is he able to see what is happening at the background? If you want to look at the top of the tower, he has to completely open up. And if you want to look at the bottom of the tower, he has to completely look at down. And he don't know what is happening at the background. So when you look at it in a vertical angle, you can only cover one half cycle, but not the other. So that is the ranging from theta ranging from 0 to 180 degrees. So whereas it's the quite different case when you are talking about phi. So suppose let us say this is your x-axis, positive x-axis, right? And the person is facing in the x direction. So his position will be 0 degrees. And let us imagine that you are moving horizontally. I mean, you are standing on the ground and you are moving it completely. So you have the ability to cover a complete rotation in a horizontal plane. So that's why the phi is ranging from 0 to 2 pi. I can say this could be a perfect example. So you can really understand the range of phi and theta. So anybody having questions right now? So we have come across a rectangular, cylindrical and spherical. So do you have any questions?
Audio output, audio output. Audio output capture.
Someone of you can kindly give the feedback so that I can understand because I can't see the chart here at the moment.
ఓకే ఇప్పుడు మైక్ ఆఫ్ చేసుకోవాలా?
So once if you understand this particular portion means the rest of the things is application part. So I would like to see how much you understand. That's what I'm going to do in the next session. That is called your conversions. So there are a particular instances where you want to convert from rectangular to cylindrical and cylindrical to rectangular, vice versa, etc. Right? So let us start with the first case. You want to convert the rectangular to cylindrical. So what is my goal here? I want to convert your x, y, z in terms of rho phi z. In the second case, sometimes, you have to convert your rho phi z in terms of your x, y, z. So this is what my objective right now. So I'm not going to explain anything, already you understood the basic definitions. Once again, I would just like to brush it up. So if you look at the definitions here, this is your x-axis, y-axis, z-axis. So let us assume that initially the point P is in the space. For an explanation purpose, I have projected the point into ground plane. So the first thing you already know, the distance from origin to the projected point is nothing but rho. And the distance of this point from the xz plane is nothing but y. The distance of the point from yz plane is x. And the moment once you draw the radial line, and if you measure the angle from x-axis, you can define it as phi. So all these definitions are clear for you. Now what I'm trying to do, whatever the portion, if you are seeing it right here, right? So this I can call it as a parallelogram, which I will draw it in a different fashion so that you can understand better. So whatever this portion, I would like to represent it vertically. So how it looks like now? So as you can see, this has become vertical like this right now. So this is your x, and this has become like this, y. And this is your radial distance. This is rho. So as you can see, there is a right angle triangle here, 90 degrees. And what is this angle? Phi. You can represent here phi. Yeah. So let me highlight this particular right angle triangle. Yeah, you can look at this particular right angle triangle. And what happens when you apply cos phi here? So when you apply the cosine of phi, that is adjacent side x divided by the hypotenuse. So I can say x is equals to rho cos phi. Similarly, when you apply sin phi here, that is the opposite side, which is nothing but y divided by the hypotenuse rho. So y is equal to rho sin phi. And as usual, right, in a rectangular and cylindrical, the definition of z remains same. So you won't find too much difference. So I can say x is the rho cos phi, y is rho sin phi, and z remains same. So are you facing any difficulty in understanding this? Or is it clear? Okay, just give me 1 minute time to you. So what all you guys will do, you know the conversions, right? X, Y, Z in terms of rho phi Z. Using all these three equations, can you tell me what is rho phi Z? You just manipulate these three equations and someone of you can let me know what could be the answer. Right? So as you can see that x is equal to rho cos phi, y is equal to rho sin phi, and z equal to z. So what is the conversions, right? Yeah.
Shiva, 1 minute. Shiva, are you full screen better, Shiva?
Yeah, yes, sir. It is in full screen only because it is an iPad, right? It looks like that.
Okay, okay. Okay. No.
Because it's not the system. Yeah.
He has to completely opens up his.
I think are you? Is the letters are visible, sir? Completely?
It's visible.
Okay, but because of the iPad, you can get some compressed size in the system.
Okay.
Yeah.
Rho equal to root over x square plus y square, sir.
Very good. What about phi?
Y tan inverse y by x
Good.
and
And
z equal to z.
Excellent. That's a good thing. The moment once you are getting into the flow, right, you can find everything is easy. So now you have understood, right, what is the each and every parameter, and you have seen the application part of it, right? And because of that, you are able to explain all these things. That's a good thing. Okay. So without wasting much time, I'll go to the cylindrical to spherical. And one more thing, anyhow, you need not to note it down, all the things. By the end of the presentation, I would like to share the presentation with you guys so that you can go through that. And if you have any questions, you can revert it back. Yeah. So next, see the conversions from cylindrical to spherical. And we had the conversion from rectangular to spherical at the last. Then we'll have a break. Yeah. Next for another 10 minutes, you bear with me. Yeah. So in the cylindrical to spherical, I can see that this is your x-axis, y-axis, and z-axis. So initially the point is in the space. So what is the first thing? The distance of the point from the z-axis is rho. So since this is rho, I can represent the same thing. This is also rho. And the distance of the point from xy plane is nothing but your z. So as you can see, this distance is same as this one.
If you want to look at
So
the
this is
top
your
of the
z.
tower, he has to completely open up.
So the distance from origin is r,
He has to completely look at down.
and the angle from z-axis is theta. So everything is clear. So just for the mathematical purpose, whatever the parallelogram you are seeing it, I will draw it vertically. So
So that is the ranging
this
from
is how it
theta
looks
ranging
like.
from 0 to 180 degrees. So whereas it's the quite
So you
different
have
when
this
you are
particular
talking about
side,
pi.
which is same as
So
your
suppose,
z,
let us say this is your x-axis, positive x-axis,
and you have the
right?
hypotenuse here, which is nothing but r,
And the person is facing.
and there is a theta, which is defined here. And this rho, you can represent here. So let me highlight this particular right angle triangle. Yeah. So again, the same rule, right? So when you apply sine theta, if you look at the right angle triangle, and if you apply sine theta, it is nothing but rho by r. So your rho is equal to r sine theta. And similarly, when you apply cos theta, that is adjacent side divided by hypotenuse. So z equal to r cos theta. So when I summing it up together, you have rho is equal to r sine theta, and phi remains same. In both cylindrical and spherical, there is no change in phi. You can notice that. And z equal to r cos theta. So can somebody say what is the reverse conversions right now? So I want r theta phi in terms of rho phi z. You can do something and you can let me know what is the answers you are getting.
So his position will be 0 degrees.
R equals square root of rho square plus z square.
Good. What about theta?
Tan inverse of rho by z.
Excellent. And what about phi?
5.
Yeah, good. Great. So just you can do the manipulation of all these three equations and you just verify whether the same
And
thing
let
is
us
coming or
imagine
not.
that you are moving horizontally. I mean, you are standing on the ground and you are moving it completely.
So let us go to the
we have
next
to
last conversions.
cover a complete rotation in
This is
horizontal
something tricky, you can do it in your
So that's why the
academics.
phi
You know the
equation is
conversions from
rotating
A to B, that is rectangular to cylindrical, and you know the conversion from B to C,
audio
cylindrical to
set.
spherical. Now it's easier for us, to
phi.
get the results from A to C,
So it
rectangular
might
to
be
spherical and
yeah.
vice versa.
So
But again, anyhow, no need here to do that kind of logic here. So let me explain with the geometry. As you can see here, again the same rule, x-axis, y-axis, z-axis. So once the point is projected into the ground plane, this is nothing but z. So just now in the previous conversions, right, you have seen z equal to r cos theta, right? And the distance here it is x, and this is your y, and this is your phi. And the distance from origin to this projected point is rho. So since you already got rho is equal to r sin theta, I replaced it like this. So what you can do, whatever the portion you are seeing it here. So let us draw vertically. So I had, this is my x-axis, this is my y-axis, and the hypotenuse is r sin theta.
we have come across a rectangle
And this is my angle phi.
spherical. So do you have any questions?
So you can
Audio
make a
output,
right angle triangle here. So this is nothing
Audio
but your
output.
90 degrees. So what is nothing but
Audio
your cos
output
phi right
capture.
now? So cos phi, when you are measuring it here,
Someone
that
of
is
you can
x
kindly
divided by the
complete that so
hypotenuse.
that I can understand. Because I
So
can't
x
see
is
that.
equal to r sin theta cos phi.
ఓకే ఇప్పుడు మైక్ ఉంది మైక్ ఆఫ్
So
చేసుకోవాలా
similarly, when you are applying a sin phi, so once if you understand
That
this particular portion means the rest of the things is the application part. So y is equal to r sin theta sin phi. That's what I'm going to do in the next session. That is called your conversation. And the value of z you already got in the previous so there are a particular instances so the value is nothing but to convert from rectangular to cylindrical and cylindrical to rectangular, vice versa, etc. Right? So what about the reverse conversions now? Can anybody say what is the reverse conversion? You want to convert the rectangular to cylindrical. So what is my goal here?
Over x square plus
I
y
want to
square plus
convert
z
your
square.
x, y, z. Excellent. What about theta? Rho phi z.
Tan inverse root over x square plus y square by z.
In the second case, sometimes you have to convert your rho phi z
Tan inverse 5 by x.
in terms of your x, y, z. Great. So this is what my objective. So just manipulate this. So I'm not going to explain you can get all this. Already you understood the basic definitions. So as a summary, just like to brush it up in a table so that similarly, rho is equal to r sin theta. So the first thing you already know, the distance from origin to the projected point is nothing but rho. And rectangular to spherical, and the distance of this point from the xz plane is nothing but y. And y is equal to the distance of the point from yz plane is x, and z equal to r cos theta. And the moment once you draw the radial line, so in the same way I have provided another table. You can just do some exercise, and you can fill this particular. So all these definitions are consider take it as an assignment. What I'm trying to do, whatever the portion, if you are seeing it right here, right. So the basic agenda here is this, I can call it as a parallelogram concept of the coordinate system. Draw it in a different fashion so that you can understand better. How good you are able to imagine the things. So whatever this portion, the visualization part, I would like to represent it vertically. That area, how it looks like now. The subject is very interesting. So as I already defined, so as you can see, this has become vertical like this right now. The first thing what you need to concentrate was look at the diagram. And this has become like this. Exactly interpret the data. Why? So once if you are questioning yourself, and this is your radial distance. Answer is yes, then you are in the right track. So as you can see, there is a right
So
angle
having said
triangle
that,
here.
I have
90 degrees.
attached some kind of problems
And what
also
is
in
this
this
angle
slide,
phi?
which I'm not going to
You can
discuss it
represent
right
here
now.
phi.
I am leaving it as an assignment based on the
So
knowledge
let me
what you
highlight this
acquired today.
particular right angle triangle.
Before going to the vector calculus, just take a break for 10 minutes.
Raju sir, 10 minutes is fine?
Yes, sir.
Yeah.
So right now the time is 11 o'clock. We'll be back again at 11:10. That could be fine,
11:10.
right?
Sure, sharply. So all the students, you can join at 11:10.
Yeah. So I will be muting myself, sir, but I will be in the call. Okay.
Just you can meet it, sir. No need
Yeah.
to left to the no need to left, sir.
Yeah. Right. I will be
Okay.
mute myself.
Okay,
Yeah.
sure. Okay. Thank you, sure.
Yeah.
Okay.
Yeah, you can look at this particular right angle triangle. And what happens when you apply cos phi here? So when you apply the cosine of phi, that is adjacent side x divided by the hypotenuse. So I can say x is equals to rho cos phi. Similarly, when you apply sin phi here, that is the opposite side, which is nothing but y divided by the hypotenuse rho. So y is equal to rho sin phi. And as usual, right, in a rectangular and cylindrical, the definition of z remains same. So you won't find too much difference. So I can say x is the rho cos phi, y is rho sin phi, and z remains same. So are you facing any difficulty in understanding this?
or is it clear? Okay, just give me 1 minute time to you. So what all you guys will do, you know the conversions, right? X, Y, Z in terms of rho phi Z. Using all these three equations, can you tell me what is rho phi Z? You just manipulate these three equations and someone of you can let me know what could be the answer.
Sir?
మేడం
Sir,
చెప్పండి మేడం.
break
sir.
okay.
వచ్చినా మేడం.
Okay.
Yeah, just now. I came back.
Okay, sir.
Are you able to hear my voice, sir? I mean,
Yes,
you can see
sir.
my screen.
Yes,
What about
sir.
my screen? Yeah.
Yes.
Okay. So I hope everybody will be back by this time.
Yeah.
And yeah, so
100
let us
hours,
start.
sir.
Yeah, right, sir. So let us
Somebody
start
they
with
are
the
joining
vector.
a YouTube link also.
Okay. Right. So let us start with vector calculus as a continuation part of that. This is basic mathematics, which we already studied. Just I will brush up a few concepts which we already studied it, right? So looking at the definitions of the vector and what do you mean by a unit vector, etc., right? So suppose let me consider this is an origin, basically, which is a reference to define any vector, right? So I had 2 points, point A and point B. So I want to define a vector joining from A to B. So I called it as R bar. So for an instance, let us assume that the point A is located at 1, 2, 3, and point B is located at 4, 5, 6. Let us imagine that. How to write a vector joining from A to B. So which is same as your vector R bar. So the vector is always the difference of the position vectors of the final point minus initial point. Vector that is the final point minus initial point. So I can say that is the position vector of B minus position vector of A. So which indirectly nothing but 4, 5, 6 minus 1, 2, 3. So which results in 3, 3, 3. So what do you mean by that vector 3? Along the x direction you have a magnitude 3 and the x cap. And the y component will be 3 into ay cap. And the z component will be 3 into az cap. So the vector is not only associated with a magnitude, but also it is having a direction, which is represented by ax cap, ay cap, az cap. Or in terms of cylindrical, you can say rho phi z, spherical or theta phi. Okay. So this is the fundamentals anyhow, which you already know. I don't want to spend too much time on that. Let us define about what is an unit vector. So you have a vector joining from A to B. You characterized it as R bar. Now I want to define a unit vector in the direction of R bar. So it is how you are going to define the original vector divided by the modulus. Okay, so what is in this particular example, that is 3ax cap plus 3ay cap plus 3az cap divided by, if you take the modulus, what is the value of modulus here? You can get 3 root 3. Right? So one point which I would like to mention it very particularly here, because in your core electromagnetic theory, you will be talking about electric fields and you will be talking about magnetic fields and the direction. When somebody says you what is the direction of your electric field, you should quantify the direction of electric field with a unit vector. Remember, it's not the original vector. Suppose, let me say I was traveling in the x direction and I was traveling in for 5 meter distance. So if somebody asks you what is my direction, I should not say phi ax cap. I should say ax cap. So what is an important note which I would like to mention? So when anything is specifically asking about the direction is always characterized by a unit vector. So you remember the same concept even for electric fields. When somebody asks you what is the direction of electric field, you should not say the original vector. Instead, you should say the unit vector in that direction. I hope the point makes sense. I have seen a lot of people who was misunderstanding between the direction and the original vector. So when somebody says a direction, it's a unit vector. It's not the original vector, right? So and the next basic fundamentals, if you are talking about the dot product and cross product, right? And you have two vectors with a certain angle. So what is the dot product? Quickly we can recollect. A bar dot B bar will be mod A bar mod B bar into cos theta. Right? And the cross product